Hello everyone, I am Dr. Krishna Sarker. Here in this session, I will be going to discuss about polar and Nyquist plot for type 1 system. This is lecture number 52 and lecture series on linear control systems. Example 2, the open loop transfer function g of s, h of s equals to 1 by s into s plus 1. Draw the polar plot and Nyquist plot and decide or determine the stability of the systems. Stability means open loop and closed loop stability. So what is the given open loop transfer function? G of s, h of s equals to 1 by s into s plus 1. This is type 1 system because at origin only one poles. What is the given open loop transfer function? The given open loop transfer function g of s, h of s equals to 1 by s into s plus 1. In this case, 1 by s to the power n equals to type n system. And in this transfer function, n equals to 1, that means 1 by s to the power 1. That's why this is type 1 system. Type 1 systems. So what is the pole 0 location? What is the pole 0 location? At s equals to 0, one pole and another pole s equals to minus 1. That means the poles locations are s equals to 0 and s equals to minus 1. So what is the plot, pole 0 plot? What is the pole 0 plot? Suppose this is the real axis and this is imaginary axis. This is real axis, this is imaginary axis. And the poles locations are s equals to 0 and s equals to minus 1. This is the left hand side and this is the right hand side. In this case, all the poles left hand side of the S-plane. That's why open loop system stable. Open loop system stable. Open loop system stable. So first point, pole 0 location, all the poles left hand side of the S-plane, all the poles left hand side of the S-plane, the open loop system is stable. Then draw Nyquist path. Step number 2. Step number 2, draw Nyquist path. Step 2, write down here step 2. Draw Nyquist path. So what is the procedure? Suppose this is the real axis and this is imaginary axis. S is equal to 0, one pole, and S is equal to minus 1, another pole. And the Nyquist path just, this is the imaginary axis path, and draw contour clockwise direction. This is minus imaginary axis, this is minus real axis, and this point minus j infinity. This is the minus j0 plus j0, and this point plus j infinity. And this path weight C1, this is the C2, this is the C3, and this path weight C4. Then draw, and this radius infinite r tends to, and the small radius, this is also epsilon, and epsilon tends to 0 but not equals to 0. So in this case, s equals to limit r tends to infinity, r into the power j theta. Then what is the weight of path? C1 belongs to minus j infinity. This is the minus j infinity to minus j0 to minus j0. Then C2 belongs to minus j0 to plus j0. C3 belongs to plus j0 to plus j infinity. Similarly, C4 belongs to plus j infinity to minus j infinity, the Nyquist range. So this is the Nyquist path. This is the Nyquist path. Then put sinusoidal input, step number 3. Put sinusoidal input, that means put s equals to j omega, sinusoidal input. For sinusoidal input, for s equals to j omega, then the open loop transfer function g j omega is j omega equivalent to 1 by j omega 1 plus j omega. And for sinusoidal input, g of j omega, h of j omega equals to magnitude g j omega and angle of g j omega h j omega. G of j omega h j omega angle. And this is equivalent to, again, we can write magnitude m and angle phi. So this is the magnitude and phase angle. And step number 4, magnitude calculation. First, magnitude calculation. What is the magnitude? In this case, mod of g j omega, h j omega equals to magnitude. Equals to what? 1 by root over 0 square plus omega square and 1 square, a square plus b square actually. A square plus b square, then 1 by omega into root over 1 plus omega square. This is the magnitude m. Then phase angle calculation, step number 5. Phase angle calculation. Phase angle calculation. So what is the phase angle? Phi equals to angle of g j omega h j omega equals to minus 90 degree for 1 by j omega and minus tan inverse B by A. This is for 1 by 1 plus j omega. Tan inverse B by A minus tan inverse B by A means omega by 1. So this is the phase angle. Phase angle equals to minus 90 degree tan inverse omega by 1. Then calculate frequency, magnitude, and phase angle. Then calculate step number. What is the step number? Step number 6. Step number 6. So write down step 6. Omega, m, and phi. Frequency, magnitude, and phase angle. Frequency always 0 degree. So what is the equation? Equation equals to magnitude equals to 1 by omega 1 plus omega square, and phase angle phi equals to minus 90 degree minus tan inverse omega. Put here omega equals to 0 first value, something by 0, infinity. And phase angle, this is 0, then only minus 90 degree. Then terminating value, omega equals to infinity. For infinity, something infinity, magnitude equals to 0. And put here omega infinity. Put here omega equals to infinity. Then this is minus 90, minus 180 degree. Minus 180 degree. Similarly, put 1. Then what is the magnitude? Magnitude m equals to 1 by 1 into root over 1 plus 1 square. That means 1 by root 2 equals to 0.707. So magnitude equals to 0.707. And angle equals to what? For 1, put here omega equals to 1. Then this is 45 degree, minus 90 degree, minus 135 degree. Minus 135 degree. Suppose 2, then this value 0.223, I think, and minus 154 or 155.4 degree. So what is the, this is 1.3.5 degree, 4 degree. Then draw the polar plot. What is the design of polar plot? Just real and imaginary axis. Draw real axis. This is imaginary axis. Plus a imaginary minus imaginary. And this axis real axis plus and minus real axis. Then this is omega equals to 0, m equals to infinity, phi equals to 0 degree. And in this case, omega equals to 0, m equals to infinity, phi equals to minus 90 degree. Omega equals to 0 degree, m equals to infinity, and phi equals to minus 180 degree. And this is omega equals to 0 degree, 0 rad per second, m equals to infinity, phi equals to minus 270 degree. At origin, what is the value? Omega equals to, at origin, infinity, and m equals to 0 at origin. So in this case, this is the first value. Put this value On the minus 90 degree phase angle, magnitude equals to infinity and frequency equals to 0. So suppose this is 1, 2, 3, dot, 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 break point. This is the value omega equals to 0, m equals to infinity, phi equals to 90 degree. Then minus 90 degree. The second point, this is the terminating value, and m equals to omega equals to infinity, that means origin. Also, m equals to 0, that means origin. And the direction minus 180 degree. This is the direction. Then third point, 1, omega equals to 1, magnitude equals to 0.707, 135 degree angle. This is the 135 degree angle. And this is the point, omega equals to 1, m equals to 0.707, and phi equals to 135 degree. Similarly, for 2, this is the angle, this value, omega equals to 2, m equals to 0.223, and phi equals to 1 minus 153.4 or 5 degree. So just this is first point, this is second point, this is third point, and this is the direction minus 180 degree. So this is the polar plot. This is the polar plot. This is the polar plot. Then draw Nyquist plot. Nyquist plot. What is the Nyquist plot? Just mirror image. This is the omega equals to 0, m equals to infinity, phi equals to 0 degree, omega equals to 0, m equals to infinity, phi equals to minus 90 degree, and this point omega equals to 0, m equals to infinity, phi equals to minus 180 degree, and omega equals to 0, m equals to infinity, and phi equals to minus 270 degrees. Suppose this is polar plot. This is the polar plot. And the mirror image, this is the mirror image. So total path, actually Nyquist. Then draw ending to sending, last point to first point, one contour, clockwise direction. Draw one contour, clockwise direction. Then we get, this is the clockwise direction contour. This is the clockwise direction contour. And totally system, this is the closed loop, because ending and sending, closed path. And this point minus 1 plus J0 point. This path minus 1 plus J0 path. Then determine the stability of the system. What is the stability? N equals to P minus Z. In this case, no contour. That's why N equals to 0 and no open loop poles in the right hand side. So P equals to 0. Again, Z equals to 0. So Z equals to 0 means closed loop system stable, and as well as open loop system also stable. So in this case, the given transfer function, open loop and closed loop, both are stable. So what is the conclusion? Stability. Stability. Open loop system stable, because all the poles left hand side of the S plane, and closed loop system also stable, because z equals to 0. If z has some values, system will be unstable. So our conclusion for given open loop transfer function, the Nyquist plot stable and also open loop system stable. So thank you.